Hello everyone, it's Mahfuz Anik. Today I'm gonna present our poster paper, Assemble-Based Approach Using Pre-trained Models for Fake News Detection in Dravidian Language. So let's begin. So social media has revolutionized news consumptions with speed and accessibility, but has fueled the spread of fake news, intentionally misleading content designed to devise and manipulate. Detecting such misinformation is especially difficult in low resource language like Malayalam due to code mixing, dialectal variations, and limited dataset. This study fine-tunes pretend transformer models for the DravidianTech 2025 shared task, aiming to build a scalable fake news detection system for linguistically diverse and underrepresented languages. Let's go for the problem statement. So for the problem, we got two task. The first task was to perform binary classification of social media posts, which was Twitter, Facebook, and YouTube. And there was two category. One was fake and original. We need to detect the fake or original post. Then the task was perform a multi-class classification of Malayalam news articles into one of five categories. They are false, half true, mostly false, partially false, or mostly true. So overall goal was to develop robust transformer model based capable of handling the linguistic complexity, code mixing, and limited resource language in Dravidian language. Now our system description. For the data pre-processing, we for the non-numerical labels, we convert it into numerical format. Also tokenizer with a pre-trained model tokenizer. Then for the sequence length, we used 512 tokens for task 1 and 128 tokens for task 2, and we remove invalid or missing data. Also, oversampling applied to underrepresented classes, especially for task 2 to reduce class imbalance, and we will use the CLS token embeddings for capturing semantic meaning. For if you say model, then for task 1 we used Malayalam but fake news Dravidian model, which has 238 million parameters, and classification head, we use hidden dimensions, size was 7, 8, 16, and 512, and we also use soft max function. For the task 2 we used I3 cube Pune Malayalam part model, and one hate speech model, which was Hindi abrasive MURI, and multi-modal assembles of CLS embeddings, same MLP structure architecture for multi-class classification. And for the training setup, we use ARAM optimizer, and learning rate was 10 to the power minus 1. 10 to the power minus 3. Then the base size was 16, and dropout was 20% for task 1 and 0% for the task 2. And framework, we used PyTorch version 2 and Hugging Face transformers, and also used GPU enabled environment. Then for the training and validation results, we got our best result, achieved F1 score of for the training set. Of course, the F1 score got 0.9794, and validation F1 score got the best for the task 1 is 0.8304, which was for the our previously described Malayalam but fake news Dravidian model. And for the task 2, you achieved best score F1 score, training F1 score was 0.9890, and validation F1 score was 0.4115. And it was for the model assembling model, which told before, this hate speech and the L3 cube model. Okay, for the test result, our first task performed got 0.814, performing above average, and the task 2 we got 0.1978, reflecting below average performance due to multi-class challenge. Now, if we conclude our poster, the task one demonstrate strong binary fake news detection performance even with a small data set. In contrast, task two was most challenging to us due to the presence of the fine-grained labels like half true, partially false, and complexity of code mix Malayalam text and significant class imbalance, and all which made multi-class classification harder. Some limitations we face, like small data set size limits generalization, oversampling may introduce overfitting risk, also difficulty distinguishing semantically close classes, assemble model increases multi computational cost and need for most diverse real world data set and adversarial training. So these are some limitations we faced. So that's all for from us. Thank you for listening.